Today we are going to start our chapter on arson. Arson is hard to investigate, and a lot of the explosion research happened because of Alfred Nobel. He worked on dynamite, and actually his brother was working with him and killed his brother because they had an explosion, and he was banned from the town that they lived in. Although that didn't stop his research, he continued to research. So some of the questions that we're going to talk about today are, what are the equations for fire, kind of relating it to chemistry? What does energy have to do with it? The heat of combustion, and the difference between exothermic and endothermic. Okay, so here are some notes that I want you to write down. Why is arson hard to investigate? Well, we talked about Alfred Nobel and his explosive research. The proof of arson is very difficult. A lot of times, if they used a liquid accelerant, it's everywhere. It's not just at one place where the fire started. Also, liquid accelerants are in your home, in places of business, and so when the fire starts, you're going to see part of that liquid if it keeps the fire going, which is hard to see if that started it or something else. You have to have a motive or pattern of operation, and the forensic investigator is in charge of stating the chemicals at the scene and trying to reconstruct the scene to figure out what happened. The investigator is also allowed to go into the arson investigation place and figure out what's going on as fast as possible. They can go in before 24 hours is what you really want to try to do, because that accelerant is going to evaporate and you're not going to have those chemicals there to investigate. They do not need a warrant to go into an arson scene, and that is because they understand the importance of getting there fast in order to investigate this and see if this was an arson case. The destruction is very extensive, and the liquid is everywhere, not just at the origin. Okay, so let's talk about the chemistry of fire. In order to have a fire, you have to have some type of oxidation. You have to have oxygen there. Imagine lighting a match or lighting a candle or trying to get a fire going or a flame. You have to have that oxygen in order to get that going. And the equation that we're going to look at, and those A's are supposed to be arrows, but I couldn't get it like that. Okay, so if you have a hydrocarbon, you have a hydrogen and carbon bonded somehow together, methane, ethane, propane, all of those if you'll remember, added to oxygen, that is going to yield carbon dioxide and water. And if you'll remember from chemistry, we had 5 different types of equations, and this is one of them, and this is called combustion. And with combustion, you always have the same products, CO2 and H2O. You need energy to get the fire going, and sometimes to keep it going, and sometimes you need new energy in order to add into that equation. You can get it from gas through the air, or you can add in other energy. During this fire, bonds are breaking and new ones are forming. So energy, we talked a little bit about it. If you have taken physics, you know that energy is the capacity for doing work. There are many different forms, and it can be transferred during the reaction. It can be transformed during the reaction. For example, if you're burning methane gas, CH4, for the purpose maybe of heating water to produce steam in order to get a machine going, you are converting chemical energy, which is burning that gas, into mechanical energy, which is to get that machine going. There are 6 forms of energy that I want you to know. The first one is heat, then electrical, mechanical, nuclear, light, and chemical. Okay, so we've talked about combustion reactions, but we also can calculate the heat of combustion. All oxidation reactions, which means it's a substance plus oxygen to yield a new substance, or combustion reactions, which remember the products are CO2 and H2O, give off more energy than what's put in. So that extra energy, you can calculate the heat of combustion. It's called the heat of combustion, and it's in light or heat form. If you've taken honors chemistry or AP chemistry, a lot of times you've calculated that heat of combustion for different reactions. If your reaction gives off more energy than what's put in, and you can calculate that heat of combustion, it's also an exothermic reaction, which means that it is giving off energy. However, if you have a reaction that takes in or absorbs energy more than it's giving off, you have an endothermic reaction. And I'm sure you've heard the difference between those before. Exo, like exit, giving off, or endo, in, taking in more energy than giving off. Okay, so during this unit, we are also going to study a case. But since you have your project, you will not have to do a case study for this. We are going to talk about Cameron Willingham. This was a big case in Texas, who was executed for allegedly setting a fire that killed his 3 girls. Him and his wife had gotten into a fight. She left to go shopping. This was during Christmas time. He apparently went to bed. He gated the kids in their bedroom, gave them bottles so that they could go to sleep. And the next thing he knows, there is smoke everywhere. They're screaming for him. He apparently tried to get them but ran out. The neighbors said they don't think that he tried hard enough to get them. And he was accused of setting the fire on purpose, angry towards his wife, towards their situation, etc. A couple days prior to him being executed, he got the death penalty. He was found guilty. They found new evidence, and they came forth with that evidence to the governor to sign the petition to stop the execution. But the governor refused to do so, and he was executed. A lot of people think that he was an innocent man, and that Texas executed an innocent man who did not commit this crime. During class, we will watch part of his story, but right now I want you to read about it. Please read the first page of this. I'll scoot it up in one moment. I'll let you read for a little bit. This is as much as we're going to read today. Okay, so every day we are going to have a quiz on what you learned the night prior. So I just want to review what is on the quiz for tomorrow. So as I go through these questions, I want you to figure out the answer and try to answer them from what you've learned tonight. What is oxidation? Do all oxidation reactions have to produce an enormous or huge amount of light? What is energy? What is an example of turning chemical energy into mechanical energy? Remember, this is transforming energy during a reaction. And what's an example of that? When energy is taken in, are we forming or are we breaking bonds? And the last one is, what's the difference between exothermic and endothermic? Okay, see y'all tomorrow.